As we were earlier stating, we said the MSCR is broken down into two categories. We have the sequential mechanism and we have the non-sequential mechanism. Alright, in the sequential mechanism, we explained that it involves two substrates binding to an enzyme before the release of any product. So two substrates, emphasis on two substrates binding to an enzyme plus an enzyme before the release of product. Before the release of product. That's a very interesting one. And we were able to find out that without the binding, let's write that out. Without the binding of the substrate to the enzyme, without the binding of the substrate to the enzyme, there is no product is made or released. No product is being made and no product is released. So two categories exist under sequential mechanism. Did you see that? Two categories exist under sequential mechanism. Remember, from multi-substrate enzyme reaction, we have sequential mechanism and the what? Non-sequential mechanism. So sequential mechanism, two categories exist in the sequential mechanism. Let's write that out. Sequential mechanism. Is that okay? Two categories exist here. The first is what we know as the random. Did you see that? Random. Random. And the second is what we know as the compulsory. Did you see that? The compulsory, ordered, or the defined ordered. Random or the compulsory ordered stroke the defined ordered. Now, something is very interesting here. You see, for the sequential mechanism, for the sequential random, now let's explain each of them. I want to explain the random first. For the sequential random mechanism, you see here the substrates, as it were, the substrate can bind. Hey, glory to God. Emphasis on bind, please. The substrate can bind to the enzyme in any fashion, or any order. The substrate can bind to the enzyme in any order. For example, for substrate A and B, you see A can bind first. You see that? A can bind first. You see that? And then B will bind afterwards. Is that okay? And then B binds next. Is that okay? So A can bind, or better still, or B can bind first. Is that okay? And A binds next. You see that? So is either A goes in and then B follows, followed by B, or B goes in and then A follows. So that is what we call the what? The random mechanism. So it's under the category of sequential. There are two types of sequential. We have the random and we have the compulsory order. What we are defining now is the what? Is the random mechanism, which is under the what? The sequential mechanism. Is that okay? Now, after that, we have what we call the now, example of this. Let's give an example quickly. In the sequential random mechanism, observe that in the sequential random mechanism, random mechanisms, the substrates are not are bound, are bound in no specific order. There is no specific order. In no specific order. And the products are released, and the products are not released, sorry. The products are not released. Emphasis on not released. The products are not released. Is that okay? In no particular order. So a classical example of this, so the test question here, we have a test question. It says explain the random sequential mechanism. Explain the random sequential mechanism and give an example. So the example that we have here is the creatine kinase. In the random sequential, the creatine kinase enzyme. Is that okay? The creatine kinase enzyme. That's a very interesting one. So we found out that the creatine kinase, is that okay? Catalyzes creatine. These are the two things that it catalyze: creatine and ATP. Glory. It catalyzes creatine and ATP. These two substrates form the two substrates form what we call phosphocreatine and ADP. You see that? So in this case, two substrates are yielding two products. Did you see that? What are the substrates that goes in? We have number one, creatine. The second substrate that went in, we have ATP. Is that not? Now for the product, the first product is phosphocreatine. Second product is what? ADP. Do you see that? So ADP. So we can put that in a bracket here and say two products. Two substrates, two products. So this is a classical example of what we have as what? The sequential random mechanism. Now, again, we have what we call the sequential compulsorily ordered mechanism. Or we have what we call the defined ordered. Here, in this case, there is order. So there is organization. Everything here is organized. Is that okay? Everything here is what? Is organized. Everything here is organized. And so because of that, the order, you can say the order, is that okay? The order of the substrates, the order of the substrate binding, is that okay, to the enzyme? Binding to the enzyme is very, very important. Is that okay? Is very, very important. Substrate A must bind. So this is a must. Did you see that? Substrate A must bind. Is that okay? Substrate A must bind to the enzyme. Unlike the other one, where we have a random binding. A can decide to go before B, and B can decide to go before A. In this case, no. In sequential compulsorily ordered or defined ordered, there's organization. So it can't be like that. Okay? So the substrate A must bind to the enzyme. Is that okay? Before B binds to the enzyme. Is that okay? Before can bind to the enzyme. And the products, is that okay? And the products are also released. Is that okay? After catalysis. Is that okay? So, a classical example of this, so this is a test question. You must note that. A test question, they say write on what we call sequential compulsorily ordered. Sequential compulsorily ordered mechanism. A classical example of this is what we call the lactate dehydrogenase. Glory. The lactate dehydrogenase. You see here, the LDH enzyme is also known as LDH. It's also known as LDH. Here, the enzyme, it is very relevant. Let's put it that way. It is very relevant to glucose metabolism, LDH. Yeah, it is very relevant to glucose metabolism. And then LDH exhibits this particular mechanism. This is what we call the sequential compulsorily ordered. Yes, exhibit it in the sense that with the LDH, let's do that. With the LDH, is that okay? The coenzyme, which is NADH, is that okay? Always binds first. So emphasis on always. You can be asked to give an example of the sequential compulsorily ordered. Always binds first. Always binds first. Did you see that? Always binds first. With the pyruvates. Is that okay? With the pyruvate binding afterwards. So during this reaction, what do we have? The pyruvate is reduced. The pyruvate is being reduced. The pyruvate is being what? Is being reduced to what we call to lactate. While the NADH, is that okay, is oxidized. The NADH is oxidized to NAD plus by the enzyme. So that's why we said, you can see that there is organization here. Yes, there's organization here in sequential compulsorily ordered, because without that organization, it should just be random, right? It should just be random ordered. Is that not? So, and we have given a classical example. We said lactate dehydrogenase is the best example so far that can exhibit a sequential compulsorily order, although we have several examples also. Now, moving forward, we now talked about what we understand by the non-sequential mechanism. In this category, we know it as, it is also known as what we call the ping pong bye-bye mechanism. So the ping pong mechanism. And so the test question is explain the ping pong mechanism. Explain the ping pong mechanism. So ping pong mechanism is also known as the what? The non-sequential mechanism. Or it is also known as also known as what we call the double displacement. Yes, the double displacement reaction. Yes, the double displacement reaction. So all the substrate do not need to bind to the enzyme. Here, note that all the substrates do not need to bind to the enzyme. All the substrates do not need to bind to the enzyme. Yeah, before the product is released. Before the product is released. All the substrates do not need to bind to the enzyme before the product. So one substrate binds first to the enzyme, followed by the product is released. So here we are saying one substrate we bind first, then there will be a product release. Is that okay? Yeah, one substrate binds first, and then there will be a product release. So typically or typically, the product P is a fragment. The product P is a fragment of the what? Of the original substrate A. So an example of the ping-pong bye-bye mechanism. Now before I go to the example, let us know that the ping-pong mechanism is known by the change, let's put it that way, is known by the change of the enzyme into an intermediate form. Change of the enzyme into an intermediate form. Yes, the change of the enzyme into an intermediate form when the first substrate to product reaction occurs. When the first substrate to product reaction occurs. Did you see that? That is what we understand by ping-pong mechanism. So at the end of the reaction, the enzyme must be found in its original form. Notes: at the end of the reaction, in a ping-pong settings, at the end of the reaction, the enzyme must, emphasis on must be found in its original form. So no ternary complex is formed. Yes, no ternary complex is formed. No ternary complex is formed in a ping-pong. So a classical example of this that does a ping-pong mechanism is what we call chemotrypsin. An example of a mechanism of the ping-pong mechanism, chemotrypsin. Yeah. Another example of the ping-pong mechanism is pyruvate carboxylase. All right. In one of our videos, we'll go deeply into the explanation. Now, another test question we want to realize here. Is we found out that multi-substrate Enzyme reactions is classified even further. Yes, it's classified into even further according to the molecularity of the kinetically important steps in the reaction. Yes, the molecularity of the kinetically important step in the reaction. The steps, however, these steps can be unimolecular, of course, can be unimolecular, can be bimolecular, it can also be termolecular. Sometimes it can be quad molecular. Yeah, it depends on the molecularity. Is that okay? So I believe we all understand the effects. The test question, another test question we can look at is the effects. What are the effects of substrate? What are the effects of substrate concentration? What are the effects of substrate concentration in multi-substrate enzymatic reaction, LORI? So we'll be looking at that in our next video. See you.